Hello everybody, and welcome to the third tutorial on recursive function. So in this program we'll be taking a look at how we can calculate the GCD, that is the HCF of two numbers, by using a recursive function. So in case you do not already know, what is GCD or HCF? HCF stands for highest common factor, and GCD and HCF both mean one and the same thing, and GCD stands for greatest common divisor. So GCD and HCF, these two terms have the same meaning and both of them are used interchangeably. Here is an example of GCD. So here we have two numbers, say a equals 8 and b equals 4. So the factors of 8 are 1, 2, 4 and 8, and the factors of 4 are 1, 2 and 4. And out of these we can see that the highest factor which is common to both 8 and 4 is 4. So this one is the GCD or HCF. Alright. So 4 is the GCD or HCF. So there are a variety of ways to calculate the GCD of two numbers. So here we'll be taking a look at the method of calculating GCD by using repeated division method, where the last value, so the division of the division will be by will be a, that is the first number, by the second number. Alright. So the first number will be divided by the second number, that is b, and the division will continue as long as the value of b is not equal to 0. So as soon as the value of b becomes 0, what will happen is that this entire loop will terminate, and the last value of a that was there before the value of b became 0 will be returned as the GCD. So you'll be able to understand it better if we just take a look at an example. So let us say here we have a, the value of a equals 8 and the value of b equals 4. So first of all let us take a look at the process. So with the in here we are calculating the remainder and storing it in a variable called rem, and the value of rem is equal to 8 mod 4, which is equal to, so here you can see the function over here in this on the left side, rem equals a mod b. So if the value of a is 8 and the value of b is 4, so a divided by 4 gives us the remainder 0, because 8 is divisible by 4. And in the next step what we are doing is we are assigning b to a and rem to b. So a becomes 4 and b becomes 0. So in the final step the value of b becomes 0. So our logic is to return the value of a which was there before the value of b became 0, or rather before the value of b became 0. So the value of a was 4 before the value of b became 0. So this last value of a, which is 4, will be returned as the HCF of 8 and 4. So let us take a second example where the value of a is 16 and the value of b is 8. So a is equal to 16 mod 8, which is equal to 0. So a will become equal to 8, that is a equals b. So b was 8, so a becomes 8 and b equals 0, which is equal to the remainder. So a becomes equal to 8 and b becomes equal to 0. And the value of, before the value of b becomes 0, the value of a was equal to 8, and this value will be returned as the HCF of 16 and 8. Next we have another example where the value of a is 13 and the value of b is 5. So 13 is not divisible by 5. So when we attempt to divide a with when we first attempt to divide 13 with 5, we get 3 as the remainder, and in the next step a equals b, b equals the remainder, b equals to the remainder. So in this step the value of 5 is assigned to a and the value of 3 is assigned to b. And so here you can see that the value of b has not yet become 0. So here what we are doing is we are repeating the process. So this is supposed to repeat as long as the value of b is not equal to 0. So here 5 mod 3 we get the value 1. So a is equal to 3, that is a is equal to b in the next step, and b is equal to 1, which is the remainder of the previous step. And now we are executing the loop once again, because the value of b has not yet become 0. So the value of b is 1. So 3 mod 1 gives us, so rem equals 3 mod 1, that is a mod b, it gives us 1. and here the remainder is 1. So in the next step, a equals b gives us 1. So the value of a, which was formerly 3, it becomes 1, and the value of b, which was formerly 1, it becomes equal to the remainder, which is 1 once again. So now in the final step, the value of b is not yet equal to 0, so it will continue another round for another iteration. So in the last step, rem equals 1 mod 1, which is equal to 0. So a will be 1 and b will be 0. So in this step, you can see that the value of b is equal to 0. So this while loop will terminate here, and the value of a, which was equal to 1 before the value of b became 0, will be returned as the factor, common factor. So 13 and 5 have no common factors apart from 1. So when we try to find the factors of 13 and 5, this will be returned as the factor. So there are two processes. One is the recursive process and another is the non-recursive process. So so initially we were taking a look at the non-recursive method, that is the iterative method. So let us take a look at the recursive version of this particular method. So the technique is virtually the same. So here what we are doing is we are taking two numbers, that is a and b, and when the value of b is equal to 0, this is a terminating condition. Sorry, we are returning a, that is the value of a that was there before the value of b became 0. Otherwise, what we are doing is we are transferring b, we are calling the function GCD once again, and we are passing b to the value of a, and a mod b, that is the remainder of a divided by b, to the value of b. So this GCD function is being called once again, and here what we are doing is we are assigning b to a in the next function call, and in the value of b, and for the value of b we are assigning the remainder, which was done here by transferring a mod b. Alright, so this is how it continues. The process is virtually the same as that of the iterative method. Here only the process is recursive. So this function is calling itself, and it will go on and on until and unless we reach the point where the value of b becomes 0. So when the value of b becomes 0, it returns a, and then this sequence of function calling again and again will stop. So let us take a look at the program over here. So first of all, let me give 8 and 4. So here you can see, so the outputs from both the recursive as well as non-recursive functions is 4. So let us run it one more time, and let me enter 13 and 5, and the output is 1 and 1. Alright, so this concludes our tutorial on recursive function. That is the process of demonstrating or finding the GCD of two numbers by using recursive technique. So I'll see you in my next video, which will be about finding the first 10 terms of a Fibonacci series by using recursion. So that's it for now, and I'll see you all in my next video. Take care, everybody.